1 second, some problem from my side. The slide is visible.
Yes, ma'am.
Yeah, thank you. Yesterday's class, I just mentioned to you about what are the types of bitumen. Then ordinary bitumen, it's paving grade bitumen, modified bitumen binders. Either you can modify it with crumb rubber or natural rubber or polymers or plastics. These are modified bitumen binders to get some extra or some improved properties. Like if you are mixing it with the bitumen is mixed with some solvents like kerosene, naphthalene or gas oil, etc., then you will get cut back bitumen where it will be in a liquid state, right? Then or bitumen emulsion, if you are mixing this bitumen granules or small particles of bitumen in water, then it's called bitumen emulsions. Taken this also, right? Functions of bitumen, it's used in surface course or top course. Then if the traffic is very high, then you can even use it for base course also. Then it's used for the preparation of mixes, then used as prime coat of a granular base course, then as soil stabilization, which I mentioned for desert soil, then a sealer material for filling joints, cracks in cement, concrete, pavement. The requirements. What are the requirements of a bituminous material? Then based on that, you have to conduct many tests and all. So what are the requirements of that? First is it should have adequate viscosity. That heating, whenever you have to mix or if at all you have to form a bituminous mixes, you have to heat the aggregate, then bitumen, then it should be mixed. So what is the viscosity of the bitumen while you're taking? Depending on the temperature, actually it will change, right? Bitumen, when you're getting, it will be in either in barrels or drums and all. It will be in semi-solid state. When you're laying it on the road, you have to heat it to get the sufficient consistency, right? So it should have adequate viscosity for the appropriate for the which purpose you are using or what time and all, depending on that. And accordingly, you can go for either cutback or bitumen emulsion also. Then sufficient viscous on cooling, that's compact surface with no date. So it should have sufficient viscous after cooling also. Then only you will get a compact surface with no deformation, and it should be able to form a thin film around the aggregate. Why this is specified is if you are mixing this aggregate with the bitumen, the bitumen should coat the aggregate with a thin film. So how thin your film is, that's good. It should not be like too much bitumen on. So it should be, the bitumen should be able to cover the entire aggregate with a thin film. That's a form thin film. For that you have to do the ductility test. You know how ductile or how much you can expand the bitumen at this material. Then there is temperature susceptibility. Temperature susceptibility means which we have mentioned earlier in the viscosity itself. I told you the viscosity of the bitumen will change with respect to the temperature. Temperature susceptibility means when you are heating the bitumen, you know that its consistency is changing. But so how to measure it? So what is the consistency of the bitumen at some specified temperature, or to attain a particular consistency, what should be the temperature of the bitumen? That you're finding in temperature susceptibility. That's to attain a particular consistency of the bitumen. What is the temperature required for? That depends on the grade of bitumen. Actually, this bitumen is graded earlier. This grading was based on penetration test. I will explain what is that penetration test. After that, it's based on viscosity grading. Okay, so it's called as VG10, VG20, 30, VG40, etc. So for all these the bitumen grades, the temperature susceptibility is different, and this viscosity or ductility value is different. So what is that? To attain a particular consistency, that depends on the grade, right? To attain that consistency, what is the temperature required? That you're finding in temperature susceptibility. For the test, what you have to do for that is called softening point test. Then adhesion with aggregate in presence of water, water affinity between the materials used in the mix. I've explained about the stripping off. Okay. So the bitumen, if you're mixing it with aggregate, it should not strip off from the aggregate in presence of water. Either in presence of water, even without the presence of water also it should not. So if the water is present, then adverse condition is small. Right. So that's whenever you're testing the stripping test, after mixing this aggregate with water, the entire this bituminous mix is dipped in water and check whether the bitumen is stripping off from the aggregate or not. That's a stripping value test. So you should have the consistency of the bitumen should be such a way that it should not strip off from the aggregate in presence of water. So you have different materials. We have seen tar, bitumen, cutback, bitumen emulsion. Some biomaterial if you are using, you can add that also. It's bio-bitumen. Then formed bitumen means hot bitumen binder with small amounts of cold water. Or if you are just allow the bitumen will be pass through a nose. Then if you are allowing like a hot steam, then you will get formed bitumen. Okay. Then other like modified bitumen, polymer modified, crumb rubber, natural rubber. Nowadays we are using more into waste plastic modified bitumen also. Next is grading system. So what is the way how the bitumen is graded or how it is named? Earlier, like bitumen, earlier papers you can see, or it's called as 80 by 100 bitumen or 60 by 70 bitumen. These are common bitumen grades. So this 80, 60, 70, 80, 100 and all, these are penetration value of the bitumen. Okay, penetration. So earlier the bitumen grading was based on the penetration. It's called penetration grading. The test to be conducted for these penetration test, flash test. I'll explain, I'll tell you all these tests. Penetration test, flash test, ductility, solubility test, and thin film oven test. Okay, and later, because the problem with penetration testing is if your this penetration is to be conducted at 25 degrees Celsius. Okay, penetration test of the bitumen is to be conducted at 25 degrees Celsius. Kindly mute your audio. I don't know somebody. So is to be conducted at 1 second. So this penetration test is to be done for a temperature of 25 degrees Celsius. And you know that when you are testing this penetration at 25 degrees Celsius, it will have some consistency. But you can't expect the same consistency at different temperature. Say if the temperature is less than 25 degrees Celsius, the consistency will change. And other thing is, if you're heating the bitumen, especially say when you're doing the construction processes or constructing a road, you have to heat the bitumen. right? You have to heat the bitumen. When you're heating the bitumen like even to 135 degrees Celsius or more than that, you have to heat the bitumen. While you're heating also, this consistency will change. So its properties is not same as that measured at 25 degrees Celsius. That's one of the drawback, and you can see that even the viscosity or other properties will change. So next comes the viscosity grading. Viscosity grading is measured at 60 degrees Celsius and 135 degrees Celsius. Both dynamic and this kind of absolute and kinematic viscosity is measured. Then penetrate along with that you have to measure the penetration test, flash test, ductility, solubility, and thin film oven test. So the grading was based on the viscosity test also, which was not there in penetration grading. Okay, because as the viscosity you can see it depends on the temperature, whether at 60 or 135 its properties will change. So what should be the value at 60 and what should be the value of 135 specified along with the various this penetration grade, this penetration flash, ductility, solubility, and thin film oven test. So in this viscosity grading, the bitumen is designated as like VG10. This VG, viscosity grading 10, then viscosity grading 20, etc. VG 30, 40. This is a common grade. Okay. And for VG10, it should have different properties, and VG20 is having, so it should satisfy those things. And so in penetration grading, it is the common one is 60 to 70 bitumen or 80 to 100 bitumen. Then 60 to 70 means its penetration value should be in the range of it should lie between 60 and 70, 60 to 70. 80 to 100 bitumen means the penetration value will be in the range of 80 to 100. That's the meaning of 80 to 100 bitumen. Okay. And beyond this, but in India we are following this viscosity grading only as of now. There's another grading that's called performance grading. This performance grading means how I want the bitumen, because the grade of bitumen which I am using in Trichy may not be suitable for for a location or for a location of a road in like Srinagar and all. Okay, thinking its climatic conditions, its temperature is different, so you can't have the same bitumen throughout. The temperature or the normal temperature or the maximum temperature is different, right? So considering this, so this considering this either like what is the depending on the climatic or environmental conditions, you can grade the bitumen. That's called performance grade. No, it's based on the performance with respect to the climatic conditions, and or it can be like I need a bitumen like where the rutting is very less or the crack is very less. So that can be formulated in performance grading bitumen. For that you need some more sophisticated equipments required like rolling thin film oven, pressure aging vessel, rotational viscometer, dynamic shear viscometer, bending beam rheometer, direct tension tester. Okay, this viscometer, this rotational viscometer, to find the viscosity at maybe if the temperature is in normal range, okay, or even if it is high also, you can test the bitumen using rotational viscometer. Suppose if the temperature is very less, I told you I wanted to check for the properties of the bitumen to be used in Srinagar, right, where the temperature is very less. So it's not possible for me to conduct the rotational viscometer test, because I wanted to know the properties when the bitumen temperature is very less. So it will be very hard. So for that you have to use like bending beam rheometer or direct tension tester, as if you're casting a like a beam. testing this concrete beam and all small, no small beam. Similarly, you have to do the this bending beam rheometer test for this bituminous material, or direct tension test have to be conducted. Dynamic shear rheometer is again an equipment where if the temperature is in medium range, then you can test the shear properties of the bitumen using dynamic shear rheometer. This rolling thin film oven or pressure aging vessel, these are equipments to find or to get the bitumen, aged bitumen. Aged bitumen means if you are say taking the bitumen freshly, if you are taking the bitumen and testing, you will get some viscosity properties. Same bitumen, if you are just testing after 20 or 30 years, you can't expect the same properties or even the same viscosity. It will change. Okay, to find that only you are finding this to this aged bitumen. In aged also you have short term and long term aging. Okay, short term aging, that for that you can get this rolling thin film oven, and for long term aging you will get pressure aging vessel. Short term aging means if you are what it will reflect in the field, say you have to take the bitumen, heat it, then it has to be for depending upon the temperature, various of the what layer you are using, it should be heated to 134, 120, or depending upon for what you are using or which layer you are using. So it will be subjected to various temperature or while transporting. All these things are done, or it's replicated in this rolling thin film oven. So if you for bitumen, from this rolling thin film oven test, you will get the sample which is simulated to a field condition of this transportation, construction, everything. Okay, that's the rolling thin film oven test. Pressure aging vessel test is done for long-term aging. Even when you are constructing the road, it's subjected to environmental conditions, right? So after 10 or 15 years, what will be the properties of the bitumen? That is done using pressure aging vessel. Okay, so these tests are required for this PEG grading, performance grading of bitumen. So the standard test to be conducted, these are like for viscosity test. For that you have to do the viscosity characteristics like flow behavior, and this has to be done at 60 and 135 degrees Celsius. Okay, viscosity is done at two different temperature. Penetration, this will measure the hardness or the consistency of the bitumen. Softening point will measure the temperature at which the bituminous material will attain a particular degree of softening. No particular consistency, particular degree of softness, what is the temperature required. Ductility is, it's a measure of adhesiveness of bitumen and its ability to stretch. Then loss on heating. While you're heating the bitumen, how much material or it is lost. Then specific gravity is a normal, as if you are doing for aggregate and all. Specific gravity is required to find for finding the mixed design. Okay, so specific gravity. So the requirements of paving materials, I told you the bitumen is graded nowadays based on this VG viscosity grading. It's called VG 10, 20, 30, 40. This is a common bitumen. Okay. So if you're if you plan to use like VG 10 grade of bitumen, then its absolute viscosity, the minimum value, it should be 800 poises at 60 degrees Celsius. Absolute viscosity is measured at 60 degrees Celsius, and the kinematic viscosity is measured at 135 degrees Celsius. The equipment to be used to find absolute and kinematic viscosity is different. Okay, because the temperature varies accordingly, it's different. Then for kinematic viscosity at 135 degrees Celsius, the centistroke, it should be 250 minimum value. Then you have to do other tests like flash test to 20 degrees Celsius minimum. Then solubility in trichloroethylene at least 99% should be soluble. Penetration at 25 degrees Celsius with a weight of 100 gram for 5 seconds, and it should be in the range of 80 to 100. It's in 1 by 10. That's why it's written 0.1 mm. Softening point value should be 40. And the test on residue from thin film, I told you it should be tested for the aged sample also. After for that aged sample or whatever the sample obtained from this rolling thin film oven, it should be tested for the viscosity. Viscosity ratio at 60 degrees Celsius, it should be 4. Ductility after this thin film test value, it should be 75. These are the various tests to be conducted for the finding the properties of the bitumen. So depending on it, VG10 and 20, it will vary, and what is the highest code to be followed for each of the test also it's given there. And this is a requirement. So that's for the ordinary bitumen, no, VG10, 20. That's a normal, or it's called paving bitumen. Suppose if you are modifying the bitumen, if you are using polymer modified or a crumb rubber and all, see, this is for crumb and modified crumb rubber. This is for natural rubber. This for this elastomeric thermoplastic based. So if it is normal bitumen, check for the properties as per this table, which is as per IS 73 2006. If it's for modified bitumen, then it should be as per this table. Okay, depending on, then it's called PMB 120, PMB 70, polymer modified bitumen. That's 120, 170. 70 or 40 depending upon the penetration. That's why it's 120, 70, 40 bitumen. Or it should be based on the, if you are using natural rubber based, then as per this, or CRMB, crumb and modified crumb rubber based. Okay. Then let us go to the various tests to be conducted in this. One is penetration test. This is earlier I told you the grading itself was based on this test. This is a measure of hardness or consistency of the bituminous material. So basic thing in this is, so you're having bitumen. No, bitumen is taken in a beaker. You can see here. Okay. So you are allowing 100 gram weight. You are allowing 100 gram weight to penetrate this bitumen for 5 seconds. Okay, this is 100 gram. You are allowing this the bitumen is kept at 25 degrees Celsius at normal room temperature. Okay, and for that you have to the steamers. There's 100 gram. It's allowed to penetrate. You're just keeping it. If the bitumen is very soft, it will just penetrate to a more depth. The bitumen is very hard, the penetration depth will be very less. So allow it to penetrate for 5 seconds. Okay, this 100 gram is important. Then this 25 degrees Celsius, allow it to penetrate for this 5 seconds. So after after 5 seconds, you are measuring at what is the depth of penetration. That is this depth. Okay, that is noted as penetration value. Okay, that's a basic principle. So in this, it determines the hardness or softness of the bitumen, and it's measured in tenths of a millimeter. Okay, so what you're allowing is you have to allow weight of 100 gram. It should penetrate for 5 seconds. Okay, it should be penetrated 5 seconds at the temperature is 25 degrees Celsius, and a graduated dial is given here. You can see a graduated dial. Okay, in this only you have to measure. So before just at the top you have to measure the reading, then again allowing it to allow to penetrate for like 5 seconds, then again measure the reading. Okay, this difference will give you the penetration value. if the penetration value is what you obtained is 93, then it should be called as 80 to 100 bitumen. Okay, if the value is like 68, then it's 60 to 70 bitumen. These are the common bitumen. You have other bitumen grade also. These two are the common bitumen at grades which was used earlier. Okay. The next test is ductility testing. So it's a measure of adhesiveness of bitumen. So you're finding what is the ability to stretch. Okay, how your bitumen, how it is possible, how much you can stretch the bitumen. That property you're checking in this. So here this is the setup. This is called the ductility testing machine. Okay, it's there. All these equipment are there in the lab. Whenever you're back to campus, you can see that. So this is ductility testing machine. This briquette, even though in figure it shows very big, it's very small, maybe of my this palm size. So it's very small, this briquette. So you have to take the sample in this. So this is the space where you have to keep the sample. So you can see this in this picture. Okay, then this entire setup, so how your bitumen in this briquette, so it can be, you can see this can be separated. Okay, this it's not one, it's two mold, it can be separated in this figure. Okay, so it can be stretched apart. So entire setup is kept in water. Entire this setup is kept in water. This water is there. Then one end is fixed here, and other end it should be moved apart. Okay, at a standard rate it should be moved apart, and you can increase the temperature of the water also. There are provisions where you can increase the temperature of the water. It should be then you have to it should be pulled apart. If you are pulling, what will happen, it will keep on stretching, right? But at some point it will breaks. This bitumen will break at some point. That is measured as the measured. So if I'm starting with this, you can just pull it apart up to this is measured as the ductility value in centimeter. Okay. Hope you understood. This briquette is to be taken. You have to fill the bitumen. It is material inside this briquette. The entire briquette is to be kept inside the water. You can maintain the temperature also here. Then one end is fixed, other end is moved apart until the thread breaks. That is measured as the ductility value. So it's important that binder should form a ductile thin films around the bitumen. Okay, and the cross section, the minimum width of specimen is 10 mm to 10 mm. Other important, should be pulled at the rate of 50 mm per minute. A temperature is to be maintained at 27 degrees Celsius. So it is expressed as the distance in centimeters to which a standard briquette of material can be stretched before the thread breaks. That is measured as ductility. It will vary from 5 to 100 depending upon the grade, and the minimum ductility value of 75 has been specified by IRC for the different, that is, grades of bitumen. Okay. Once. Next test is softening point. So softening point, this is the temperature at which the substance attains a particular degree of softening. Okay, soften, because if you're heating the bitumen, it will get softened, like its consistency will change, or it will get softened, or it will be more into liquid state if you're keeping it. So how to tell the consistency at this temperature? What is the consistency? How to tell? So for that you have to do the softening point. It's called ring and ball apparatus. Okay. This is called ring and ball apparatus. Why it is? Because this setup, what it is shown here, this is this shown here. You can see a ring here. A ring is there and a small ball is here. That's why it's called as ring and ball apparatus. Okay. So the procedure for this is, think you'll understand with this. A small ring you can see and a ball also. So you have to take the bitumen sample. You take the bitumen sample. You have to pour it inside this ring. Okay, inside this ring. Then keep a ball or small ball. Okay, small over there. Then the entire setup is to be kept inside the softening coin test setup. Okay, this is a frame, this is temperature, this thermometer, you can measure the temperature because you are heating it. You have to heat the bitumen, its temperature. When you are heating only, its consistency will change. So you have to heat the entire setup. It's kept in water or some other solution also. So when you are heating, what will happen here? This ball is kept up. If you are heating, it will lose its consistency and starts coming up, and there's a bar is there, it will touch here. So whenever this ball along with the bitumen, it's touching this bar, that temperature is noted as softening point. Okay, I'll show you in picture. So this is the first one. So if you are heating, the bitumen will get softened and it will just come down along with the ball. So whenever it is touching this lower plate or lower bar, that you have to measure the temperature. The temperature corresponding, or whenever this ball is touching this lower bar, that temperature is noted as softening point. Okay, particular temperature. So this softening point is the temperature at which the substance attain a particular degree. That particular degree is to for the bitumen to reach or touch that plate. That particular degree of softening under specified condition of testing. This equipment, this is called ring and ball apparatus or softening point apparatus. So this requires a brass ring containing a test sample of the bitumen. This suspended either in water or you can use glycerin also at a temperature. You have to heat it, right? So the steel ball is placed upon the bitumen sample and the liquid medium is heated at the rate of 5 degrees Celsius per minute. And the temperature at which the softened bitumen touches that metal plate, metal or that bar or whatever you call it, is placed at a specified distance below the ring is recorded as softening point of bitumen. And it will for a normal bitumen, it will vary from 35 degrees Celsius to 70 degrees Celsius. You can see in these tables all these properties were specified. You can see the softening point should be 40, 45, etc. No, penetration value should be in the range of 80 to 100 if it is VG10, 60 to 100, etc. Okay, then ductility value. So for all this, the specification is there depending upon the grade of bitumen. This is the principle. You have to heat it, then when you're heating along with the ball, it will come and touch it, that temperature you measure. Next one is flash and fire point. Flash, there's a difference between, so you're finding when your bitumen will catch fire. So what is the need for finding this? So why do you want to find when your bitumen will catches fire? Why it's so much important? Why it's given here? Anyone?
From any road accidents.
Road accidents, then
Heat produced due to wearing and tearing.
heat produced due to wearing. You just think how you are constructing the road. You have seen on the roadside constructions nowadays, actually it's in plan, but earlier even for small work and all you might have seen, even small works in village you might be seeing this bitumen is heated at very high temperature, right? So you have just seen or not. So it is heated at high temperatures. While you're heating, see to that this heat is not beyond a temperature such that it will catch fire. If you're heating beyond some temperature, it will catch fire. Okay, because you have to, even to take it out from the drum or barrel, you have to heat the bitumen. Right, so you have to heat it, but see to it that it's not beyond this flash or hair point. The equipment is called Penske Martin's closed cup apparatus or open cup is there. What the shown in figure is Penske Martin's closed cup apparatus. So before that, I'll tell you what is this flash point and fire point. Because there is some difference between flash and fire point. Flash point means where if you're heating a material, if you're just heating any material, sometimes what will happen is a flash will occur, then it will just switch off. Okay, that is, there won't be any light of hair. That's a flash point, the temperature at which the bitumen, you can see just a flash. It won't burn for long. Okay, that's a flash point. Beyond that, beyond the flash point, again if you're heating the bitumen, what will happen? It will just starts burning for some time. Right, that temperature is called the fire point. So flash point will come first. Flash, if you're heating, at some point you can just see a flash alone. Flash alone, it won't burn for long, it will just switch off. One flash, it will switch off. That temperature is flash point. Beyond that, if you're heating, then it will start catching fire, it will just burn for some time. That's a fire point. Okay, so whatever the material you're testing, it has to be taken in a cup. Then intermittently, you just give the flash, where you just check whether when flash is occurring or when this fire point or when it's burning for long. So it's heated at the rate of 50 degrees Celsius to 60 degrees Celsius per minute, and a test flame and a test flame is given at intervals depending upon the flash and fire point of the bitumen. So a flash point is taken as the temperature read on the thermometer at the time of the flame application that causes a bright flash. Okay, a temperature that causes the bright flash is noted as flash point. And the fire point is beyond that, if you continue heating, the material gets ignited and continues to burn for at least for 5 seconds. If it is burning or that flash is lasting for 5 seconds, or if it's burning for 5 seconds, then that temperature is noted as fire point. Okay, so flash, whenever you're getting a bright flash alone, it's flash point. Temperature for that is called flash point. Temperature to cause the bitumen to burn for 5 seconds is noted as fire point. Okay, this I'll explain in next class. Any doubt?